So at this point, you should have a good handle on the basic sine, cosine, and tangent function. So here's the sine in front of us. You know that sine starts out at, when it crosses the y-axis at 0, then goes up to the top of 1. So this would be 1 here, and that's -1 there. And comes back down to the to the x-axis, goes down to the bottom at -1, comes back up to 0, and then begins again. So you can see this would be it would repeat itself, and it would just keep going, etc. Where it begins repeating itself is 2 pi. Okay, so we need to talk about some terminology. So the distance from the middle, so distance from the middle to the top is called amplitude. Now, when we say amplitude, so for example, if you think about back to your pre-cal 1 days, what could make my amplitude change? In other words, what could possibly stretch this up higher? Stretch being the clue there. If you remember back from pre-cal 1, if we multiplied on the outside of a function, it stretched it. So if you think of sine x as a new parent function, then if you could think of y equals 2 sine x. Well, that's just the parent function sine x that's being multiplied on the outside by 2. So that would stretch everything twice as far away from the origin. So that means, let me do a different color here so you can tell. We'll use blue. So if I wanted to graph y equals 2 sine x, well, I know that instead of going up to 1, it's going to go up to 2. But this won't change because anything that's on the x-axis is not affected by a vertical stretch, right? So we'll come back to here each time, but we're going to go up higher, come and go down lower, but still go through 0 at the same place. Okay? So then that's called the amplitude. In pre-cal 1, we called it the vertical stretch, but now we're going to give it a new vocabulary word and call it amplitude, because this has applications in the context of where we use sine and cosine. Okay? So that's amplitude. The next thing we want to talk about is the vertical shift. So the vertical shift is going to be how much you've been shifted up or down. So again, if you remember from pre-cal 1, we do that by adding on the outside. So the vertical shift is really how far the middle has been displaced. So again, if you remember that shifting moves everything, whereas stretching only moves things that are not on the x-axis, vertical stretching. So the way we tell if something's been shifted is by whether it's located around the middle or not. So notice both of these sine curves have the middle of their curve, so this halfway between the top and bottom is still on the x-axis. So if there was a vertical shift that happened, it would have been moved up or down. So the middle would not be sitting on the x-axis anymore. And just like in pre-cal 1, the way we shift things up or down is by adding on the outside. So a vertical shift would look something like this. Y equals, well, let me use a different color again. Red. Y equals sine x plus 2, let's say. So what that would look like is, so instead of the middle being here, the middle is going to be up here at 2 now. So I'm going to draw this little line that goes along here. And in this case, notice the amplitude is still 1. So I'm going to go from here. I'm going to go up 1, come back down to the middle, go down 1, and come back up to the middle. So my new sine curve is going to look something like this. Okay? So that's called a vertical shift. So that's the two things we can do on the outside. We can multiply on the outside, multiply or divide, and we can add or subtract on the outside. Multiplying is going to stretch everything, which gives us a new amplitude, and adding or subtracting is going to shift everything, which really gives us kind of a new middle. And so if I'm looking at a graph that's like, for example, y equals 2 sine x plus 1. So usually the way I graph that is the first thing I do is I recognize that the amplitude is 2 and the vertical shift is 1. So I'm going to draw a new middle because everything's been shifted up 1. And from the middle I have to go up 2. So that's going to be the top of my graph. And also from the middle I go down 2. That'll be the bottom of my graph because the amplitude tells me how far I've been stretched up or down from the middle. So then I'm going to go out here 2 pi and put a 2 pi. That's about halfway pi. That's about half of that would be pi over 2. So because I'm dealing with sine, I'm going to start at the middle and I'm going to go up to the top by the time I get to pi over 2, back down to the middle, down to the bottom, and back up to the middle. And then repeat myself. So I quickly establish where the top and bottom and middle are, and then I just draw my graph accordingly. Okay? So that's amplitude and shift. The next thing I want to talk about is period and frequency. So y equals sine 2x. Obviously that's going to do something. Remember on the inside when I multiply, that stretches things horizontally. And also remember from pre-cal 1, if we multiply on the inside, there's a reciprocal effect. So if I multiply by 2, it's not going to make it twice as long. If I multiply by 2, it's going to make it half as long because of that reciprocal effect. Okay. Now, that was a point of confusion pre-cal 1, so I'm going to tell you something in this class that hopefully will make it less confusing. So we have a name for this right here. This thing is called the frequency. It's called the frequency because it tells you how many cycles have been crammed into the normal period or cycle length. Okay? And the cycle length we call period. So a normal sine curve has a period of 2 pi because it takes 2 pi before it repeats itself. So what this little 2 tells me is it just tells me how many cycles I have in the normal 2 pi stretch. Okay? So to make it even easier, there's a little relationship here. So the cool thing is that the frequency is always equal to, with sine or cosine, 2 pi divided by the period. And of course, vice versa, that's true. The period is always equal to 2 pi divided by the frequency. Right? So when I'm looking at this thing here, this y equals 2 sine x, sine 2x, I'm sorry, sine 2x. Amplitude's normal, it's just 1. Vertical shift is 0, hasn't been shifted at all. But there's this little 2 in here. The frequency is 2, which means the period is 2 pi divided by the frequency, which means the period is pi. So what that tells me is if I want to graph this thing, I'll go back over here and do it on the same one, right? If I want to graph this thing, I have a normal sine curve except for it's been scrunched up. The period's only pi instead of 2 pi. So if I go up here and try to draw that, the amplitude is going to be normal. So I'm still going to start here at 0, 0. I'm still going to go up to 1 and down to -1. And the middle's still on the x-axis. But I'm going to have to go to the top, back down to the middle, and to the bottom and back up to the middle before I get to pi this time. So remember, pi is right here. So I'm going to go, and that would be what? Pi over 2 right about there. So I'm going to go up, back down, all the way to the bottom and back up. So you can see there's 2 cycles in the time that I normally get 1 cycle. Okay? So that is called, the number in the sequence, or the number in the equation is called frequency. But usually we take the frequency from the equation and we use that to find out the period, because the period helps me know where to begin and end my 1 cycle. So I think I'll stop there for now. We haven't talked about the adding on the inside, but we'll there's some worksheet you can practice on to get a feel for these things. But you already know if I add on the inside, that's going to shift it right or left, because we know that from pre-cal 1, right? So we'll talk more about that later. But this should get you started on graphing sine and cosine curves in general.